All right. Okay. So tomorrow we have a quiz, right? Okay. So we have a quiz over just everything we learned about last week. So just kind of as highlighting the things that you will need to remember. Okay. Nut. Okay. Noun, unit, time. Okay. Understanding how we construct a proper response for a story problem, right? These numbers actually mean something, okay? And that this works for, any type of scenario, okay? Even like knowing like what the correct units are is important, okay? So example 2 is a great example, talking about the rate of people coming into the park. So this one was, we found the derivative, we found the derivative of the derivative, right? So the second derivative, since it says the rate at which people enter a park is modeled by E of t, and we are finding the derivative of E at 6. So we said, so this was a good example. When t equals 6 hours, the rate at which people enter the park is increasing at a rate of, it was 69.2307 people per hour, okay? Because we are talking about the rate of a rate, right? So that is important. I even went back and checked a couple of AP problems. Then in a case like this, you are giving, it's the rate at which how fast people were going into the park. So noun, unit, time. Because this can be used, this will be used throughout the unit. So we'll still see some problems after the quiz as well. And then we spent a number of days talking about particle motion. So it's important that you remember this as well. Okay, so position, derivative, velocity, derivative, acceleration, understanding how those units work as well. Okay, so when we deal with particle motion, being able to answer a bunch of these questions. I think the one question that didn't come up on the homework was the total distance question. So just be mindful of that as well. Okay, when things are speeding up, when things are slowing down, explaining those. Okay, just as we talked about on the homework. And yeah, even the use of the uses of a sign chart, right? How helpful that can be. All right. And then we did have that question from this past exam. That's the old one. Where's the new one? There it is. Wait, no. Oh, that was 4.3. We had already that. We're looking for 4.2. Oh, there it is. My bad. Okay. All right. So this is the one from this last year's exam. 2 particles moving on the same line. Or they moving in opposite directions. Make sure we're reading the problem carefully. Okay, so we're given the position of one particle, the velocity of a different particle, and then seeing is speed increasing or decreasing, and then we kind of had this summary table. So one thing that is I think worth pointing out is that when we're talking about a bug or an object moving to the left or to the right, we are considering the inequality that's bigger than 0 or less than 0. So that would lead to, when we give the interval, it's in parentheses rather than braces because it's not equal to. Yeah, it's interesting because when we get to Unit 5 and we talk about where functions are increasing or decreasing, we can actually use switches to we can use braces, but that's a conversation for a different time. So, okay, and then on Friday, which you might have questions about the homework, we did how do we apply derivatives in rates of change in other contexts, right? Is that wait, hold on. 4.3. Oh yeah, 4.3. So we did that small adjustment at the end of class on Friday on example 1. That when you look at the rate of bananas being put on, comparing it to the rate of bananas being taken off, because that's what G is, that you take the difference of those. And because that is bigger than 0, that is then that the number of bananas on the table is increasing at that moment. Okay. And then you had example 2, which was another kind of calculator problem, interpreting the answer. So, alrighty. Are there any questions about that 4.3 homework?
For those last two, they just seemed, I don't know, they just seemed too simple. Like I might have looked over something because it seemed like algebraic for me instead of calculus. I don't know.
Well, let's see. Show more options. Convert. Save.
Scariest ever. You have log after today.
All right. So you're thinking about 3 and 4?
Yeah.
Okay. So 3 says the tide removes sand from Sandy Point Beach at a rate modeled by the function r. Okay, so that is removing sand. A pumping station adds sand to the beach at a rate by the function s. Both r and s are measured in cubic yards per hour, and t is measured in hours from 0 to 6. At time t equals 0, the beach contains 2,500 cubic yards of sand. Find the rate at which the total amount of sand on the beach is changing at time t equals 4. So what did you do? I'm just curious. What did you do for that?
I took the two rates and I plugged 4 into both of them, and then I did s of t minus r of t equals total change.
So then what was your answer?
2.0908.
Great.
Oh.
Yes.
It was decreasing at a rate of 2.9.
Well, here's a nice thing.
Oh, it doesn't.
It doesn't ask you to interpret the answer.
The second one does.
Yeah. Would it be negative though, or not? Because it is.
Well, but like s of t minus r of t equals tc. So
Yeah. So I did s first as well.
I mean, I guess you could do negative.
It doesn't ask for that.
I was
So
confused about that.
yeah. So yeah, 3 is
Okay.
as simple as it seems.
Then that means 4 is probably the same way. So I think.
Yes. So then 4, it says the rate at which water flows into a drain pipe is modeled by r, and the pipe is partially blocked, allowing water to drain out the other end at a rate modeled by d. So you kind of got a rate in and then a rate out.
Yeah.
So there is the amount of water in the pipe increasing or decreasing at 3? It is decreasing because d of 3 is greater than R of 3. Yep. So, because you have, you have R of 3, the rate of which the water is coming in, at 5.0864, and the rate at which it's coming out is 5.4. So, somehow, that partial block is actually speeding things up. Somehow.
No pressure.
Yep, that's true. Yep. So, alrighty. Okay. Why don't you just hold on to this until tomorrow? I'll give you. I do have a small packet of AP classroom problems that you can use. I also have assigned this digitally so that if you do this at school or something like that, you can access it online.
Are you like not here?
Huh?
Or you're like not here?
Or if you're not here, yes. Oh yes, if you're not here.
Ronald McDonald.
Yeah, there's some multiple choice. It does pretty much kind of progress through kind of topic 1 to lesson 1 to lesson 2 to lesson 3. So it's like the first 3 questions are lesson 1, 4, 5, 6, 7 are like particle motion, and then the last 4 are like from topic 3. So you can use the rest of the time to work on this. Yeah, great. And we're at 12 minutes, right?